Let's continue with our next lecture on laws of motion in this series of NEET PYQ. Our next question is, a plank with a box on it at one end is gradually raised up about the other end. Okay, fine. As the angle of inclination with the horizontal reaches 30 degree, the box starts to slip and slides 4 meters down the plank in 4 seconds. The coefficient of static and kinetic friction between the box and the plank we have to find. Okay, so basically what you do is you are increasing the angle, right? You are finding, or you are looking for an angle for which the box starts slipping down, right? So you have to find our static friction and kinetic friction. Clear? So to find static friction, straight away our static friction is nothing but mu s is equals to tan theta. The angle at which it just starts sliding down, that will be responsible for our static friction here. So mu s will be equal to tan theta, and what will be our theta here? Our theta here is 30 degrees, so mu s will be equals to tan 30 degree, correct? And what is our tan 30? Tan 30 is 1 by root 3. So that will be our mu s. Mu s is 10 by root 3, or that will be equals to how much? Root 3 by 3. Okay. Or you can make it as 1.7 whole divided by 3. So that is 0.35, 3 6 18, right? So 3 5 0.5 approximately. That will be our static friction. So nearly option C will be correct. Let me solve the other part also for you. Okay. So this is our static friction. We found static friction as 0.5. Now they are saying the box starts slipping down, okay, and slides 4 meter down the plank in, so distance it moves, s is equals to 4 meter in what time? In time equals to 4 seconds, right? It is moving that much. Okay, in that case, what will be the kinetic friction which is acting on this particular system? Okay, to figure out our kinetic friction, let me find what is the acceleration acting on it. We know that the acceleration going downward will be g sine theta, which is responsible for this block to go down, and something which stops it to go down is mu g cos theta. I hope you remember that, right? G sine theta is responsible, the acceleration downward, that is acceleration upward. Resultant acceleration is a, which is acting on the system is g sine theta minus mu g cos theta, right? Here mu, the coefficient of friction, is coefficient of kinetic friction, right? Because the system is moving downward. This is static friction, this is kinetic friction over here. Clear? So let's solve this. Okay, acceleration is this, and time is given, s is given. Initial velocity of the block is how much? 0. So s is equals to half a t square. Let me write here, s is equals to half a t square. Let me substitute here all the values and figure out this value of mu. I hope you are clear with the concept. Okay, let me repeat again. The net acceleration acting on the block when it is moving down is this much. How you got this? G sine theta is responsible for the block acting on the block to move it downward, and mu g cos theta is due to the friction, the acceleration. Okay, so resultant will be this. Okay, so distance it travels is 4 meter as per the problem, half, and acceleration, let me substitute here, let's take g common out, it will be sine theta minus mu cos theta into t square. What's the time? Time taken is 4 seconds, so t square will be 16. I hope this is clear, right? Let's take this 16, 2 here, 2 4s are 8. 8 over 16 is equals to, what you left with here? G sine theta minus, and what's the angle for sine theta here? The angle here will be 30 degree, right? Because it starts moving just after this angle. So sine theta 30 minus mu k cos 30, right? I hope this is clear. Now, this will be 8 upon 16, which is how much? 1 by 2. And that equals to g, which is, I am assuming 10, okay? Because they have not said to take 9.8. Let's assume it as 10. Sine 30, which is 1 by 2, minus mu k cos 30, which is root 3 by. I hope this is clear. Okay, so let me remove the previous one. Our first answer is 0.5. Let's see that second part. So I'm just removing this whole thing and let me solve it over here, right? So this will give you 1 by 20 is equals to 1 by 2 minus mu k root 3 by 2. Let's multiply the whole equation with 2. It will be 1 by 10 will be equals to 1 minus mu k into root 3, correct? Let's take this mu k root 3 that side. So mu k root 3 will be equals to 1 minus 1 by 10. That's 9 by 10. Clear? 9 by 10, which is approximately 0.9. Clear? And mu k into root 3. So root 3 taking on the other side, it will be root 3 now. Clear it is? Now let's multiply up and down once again with root 3 just to make the denominator as 3. So this mu k will be equals to how much? It will be equals to 0.9 upon 3 into root 3. Correct? Now that will be 0.3 and root 3 is nothing but 1.7 mm. Assuming. So this will be how much? 3 7s are 21. 3 1s are 3 and 2, 0.5. Okay. So 2 points, which is 0.5 approximately. Okay. So both are nearly 0.5. So I think we have to check for the mu s once again. So mu s, static friction, if you remember, it was tan of angle 30. So tan 30 degree is 1 by root 3. Let's find it a more closer value. So let me just remove this whole thing and let me find it little more, because 0.5 and 0.6 both are there, right? So this will be equals to how much? It will be equals to our root 3 upon 3, and that's 1.72 by 3. So this will give you 0.35 are 15, approximately 0.5, okay, 15, and 22 is how much? 3 7s are 21. So 0.57, which is 0.6 approximately. Okay, they have taken the round off. So static friction is 0.6, kinetic friction is approximately 0.5. So correct option for this one is option B. I hope this is clear. Okay, so you have to be very careful. For static friction, we take straight away mu s is equal to tan theta. For kinetic friction, we have to use the equations of motion. Clear? Let's see the next question. Great. We have done some similar kind of problems in the previous lecture. I'll just repeat the whole concept once again in case if you have directly started watching this particular video. Okay. So let me repeat the whole concept once again. Let's read the question first. A block A of mass m1. Okay. This is block A of mass m1 is resting on the horizontal table. It is resting on the horizontal table. A light string connects to it, passes over a frictionless pulley. That pulley is frictionless at the edge of the table, and from its other end, another block B of mass m2 is suspended. Fine. The coefficient of kinetic friction between the block and the table is mu k. So obviously this will be over here. This is the friction over here, and that is how much given? Mu k. The kinetic friction is given as mu k. When the block A is sliding on the table, the tension in the string. So you have to find the tension in the string T. I hope the question is clear, right? So what will be the direct answer? If you remember the direct answer in the previous lecture, we found our acceleration A. Oh, they are asking the tension and not the acceleration. So it will be 2m1 m2. Okay, we can directly find it will be m2 m1. Let me write, acceleration was m2 minus m1 g upon m1 plus m2, correct? When there was no friction in such a system. And what was the tension for such a system? It will be m1 m2 g whole divided by m1 plus m2, correct? And since here the block m1 has some kinetic friction, okay, because of that the relation will take the role of this one. Okay, it will look like this. We will prove it. So let's see how we get this particular expression. Okay, so focus on this. We'll make use of same concept. First of all, let's start with block B. So for block B, weight is acting downward, m2g, and tension is acting upward, T, correct? Okay, so m2g is downward, tension is acting upward, correct? And because of this, what is happening? We have acceleration of the system. So m2g minus tension T will be equals to m2a. I hope this is clear. Okay, this is for block B. Let's deal with block A over here. For block A, the tension is acting in this direction. The friction is stopping it in this direction. Okay, and because of that, tension T is greater than the frictional force, and that is making it m1a, the acceleration in the first block. Clear? Now what is our friction? Sir, our friction here is how much? Mu into normal reaction. And what's the normal reaction over here? So it's n, and that will be equals to m1g. So let me substitute here, mu into m1g, that will be equals to m1. This is our second equation. So this is first equation we are getting from FBD of object B, and FBD of First object is giving us the second equation, right? Now what we will do, we have to find the tension and not the acceleration. So let's eliminate the acceleration. Let me take this m2 on the other side. So this will be dividing the whole equation with m2. This will be g minus t by m2. That's equal to a, correct? Let's substitute this value of a over here and simplify to get the value of tension T. So putting it here, this will give you, the equation will take the form T minus mu m1g, that will be equals to m1 into acceleration A. And what's acceleration A? G minus T by m2. I hope this is clear. Clear it is? Okay. Now let's simplify it further. So I'm taking it as T minus mu m1g, that's equal to m1g minus m1 upon m2 into T. Fine. Let's take this T on this side. It will be T plus m1 by m2 T. I took this on the left hand side. I am taking this on the right hand side. It will be m1g plus mu m1g, correct? I hope this is clear. Be very careful with the suffix, okay? Be very careful with the suffix, okay? Where it is m1 and where it is m2. Now, great. Let's take t common out. This will become 1 plus m1 upon m2, okay? I just took t common out. And here, if I take m1g common, this will be 1 plus mu. I hope this is clear, okay? Here I took t common out. Here I took m1g common out, right? Now, cross multiply here. Let's solve it here. So, this will be t into m2 plus m1 whole divided by m2, and on the right hand side it will be m1g whole into 1 plus mu. Let's cross multiply. So tension T will be equals to m1 m2g, correct, into 1 plus mu whole divided by, taking this below this, it will be m1 plus m2. So this is the tension acting here, right? Okay. So that's our option C. In case if there is no friction, same system without friction, mu becomes 0 and the equation takes the form, previous form which I have written directly, right? So because of the friction, that equation, the tension changes, right? Even the acceleration changes, that we have seen in the previous video. If you have not seen the previous video, you can watch it. Link is in the description. Let's move to the third question. Great. Our third question says, a system consists of three masses m1, m2 and m3 connected by a string, passes over a pulley P. The mass m1 hangs freely and m2 and m3 are on a rough horizontal table. Okay, fine. The coefficient of friction is mu. The pulley is frictionless and of negligible mass. The downward acceleration of mass m1 will be how much? Okay, let me just draw it, okay, how it looks like. So there are a system, this system consists of how many masses? Three masses connected by string passing over the pulley. The mass m1 hangs freely and m2 and m3 are on rough horizontal. So this will be, okay, so m2 is over here, m2, m3, correct? m2 and m3 are on the rough horizontal table. The coefficient of friction over here is mu, fine. Okay, and they all are connected with the string, and the string is passing over the pulley. Let's say it will be like this, and this is our m1. I assume the question is like this, okay? A system consists of three masses m1, m2 and m3 connected by string passing over a pulley P. Okay, fine, this is our pulley P, and the mass m1 is hanging freely and m2 and m3 are on a rough horizontal table. The coefficient of friction is mu. The pulley is frictionless, okay, and of negligible mass. The downward acceleration of mass m1 we have to find if all the three are equal. Okay, downward acceleration, be very careful, we have to find our acceleration. In case we have to find the acceleration, let me remind you, without any friction, the acceleration formula was nothing but, it was how much? m2 minus m1, correct, into g whole divided by m2 plus m1. If you remember, this is without any friction. Okay, if you have one mass, if you have not seen how I got this particular expression, you can watch previous videos. Link is in the description. The whole playlist is there on the PYQs. There you have this whole thing. I have explained you the whole thing. Okay, so if acceleration is this when you don't have any friction. If you have friction and there is only one mass, let's say if there is only one mass, which is our m2 and m3, no, so let's say one mass is there, then in that case it will be m2 minus mu m1 into g whole divided by m2 plus m1, right? This expression also we derived in the previous lecture. Okay, just before this, the previous lecture, I have derived this expression also. We get mu m1, right? Now mu m1, because m1 is placed on a friction surface, rough horizontal surface, so that contains a friction of mu. What happens if instead of only m1 there are two masses? In that case, the same expression A will take the form m2 minus, okay, let me just write it over here so that I can remove the previous one. Just making here m2 minus, oh, okay, one second. Now, which one is freely hanging over here? M1. So let me just straight away put here M1 minus, which one are on the rough surface? M2 and M3. So mu times M2 plus M3. Okay. Let me remove this. I hope you have understood this. Into G whole divided by adding all the three masses M1 plus M2 plus M3. I hope this is clear. Okay. We can directly find it for this scenario. So as per the problem, all the three masses are equal. So let me substitute here. This will be m minus mu times m plus m. Otherwise, you can make the equations, draw the free body diagrams and simplify, you will get the same. So don't worry about that thing, you will get the same thing, okay? And how we get this same thing, that also I have explained. So again and again I am repeating this. So this will be all m adding 3m, right? So this will be equals to m minus 2m mu G upon 3m, right? Let's take m common out from this expression. So this A will be equals to m taking common out. We left here with 1 minus 2 mu into G whole divided by 3m, right? Let's cancel out this m with m. A will be equals to 1 minus 2 mu into G whole divided by 3. Let's see if there is any expression like this. Yes, we have such an expression. Option C is correct. Clear? So I hope you are clear with this particular part, right? Let's move to the next one. Great. Let's see the next one. The next question says a block of mass m is in contact with a cart. So this is a cart and this is a block of mass m. Okay, let me write it completely. This is m. Okay, fine. As shown in the figure, the coefficient of static friction between the block and the cart is mu. Okay, obviously the friction is between this place where they are in contact, right? Okay, mu is the coefficient of friction. The acceleration is alpha of the cart that will prevent the block from falling. Satisfies which one? We have done quite similar problem using an inclined plane, right? Now this is not an inclined, this is a flat surface over here, right? Let's understand it somewhat like a real life experience. If this is a block and this is a cart, okay, there is a natural tendency for this block to fall down, right? Why it is falling down? Because of its own weight, right? And what is the weight? Mg. So let me just draw a diagram over here so that you will be cleared with this thing. Our weight is downward. Let's say this is mg, correct? If something can stop it, because it can't go and simply fly in the front direction, right? It will have a natural tendency to fall down, and that is weight. And there should be something which will be against this weight to keep it in at this position, and that must be acting in this direction, and that is nothing but the friction. Clear it is? Friction between the cart and this block will be in this. You can put this vector here or you can put it over here also. It doesn't make any difference, right? So friction is stopping it. Because of this forward acceleration, there is a pseudo force which is acting on this direction, left side, and that is nothing but m times alpha. Correct? Because it is in contact with this, there will be a normal reaction which is acting in this side. Clear? So let me just redraw this diagram over here. This is our block. It has a weight downward in direction mg. Correct? It has a frictional force over here. It has a normal reaction over here, and it has a pseudo force here, which is m times alpha. Clear? Now, who is stopping this block to fall down? Of course, frictional force and weight, right? They are equalizing itself. Normal reaction is equalized by our pseudo force. So, frictional force F must be equals to mg. And F we know it has a formula of mu times normal reaction equals to mg. And what is normal reaction from this equation? Sir, it is nothing but mass times alpha equal to mg. Clear it is? Okay. Now, be very careful. Since there are no equal to's, there are greater than or less than. So, one thing should be clear. If the weight is greater than friction, it will have a natural tendency to fall down, right? But if the friction is greater than weight, then it will be stationary. So friction must be greater, friction must be greater, friction must be greater, right? Let me repeat again. Friction must be greater than the weight, and F equals to mu n, which is greater than mg, and n is nothing but m times alpha. Mm cancels. We can write alpha is greater or equals to g by mu. That must be our result from here. So alpha is greater than or equal to g by mu for this block to be stationary. Clear? I hope this is clear. Let's see the next one. Great. Another problem says a block B is pushed momentarily along a horizontal surface. This is our horizontal surface with an initial velocity V. Okay. If mu is the coefficient of sliding friction between block B and the surface, the block B will come to rest after what time? Okay. So equations of motion, or we can use Newton's second law also. So let's see first thing. So if it is moving with a constant velocity, clear? So we know that what is our Newton's second law says? Our Newton's second law says that force is rate of change of momentum, and rate of change of momentum, okay, is P final minus P initial upon time t. Correct it is? Okay. So it achieves the final velocity as V. What is its initial velocity? So 0. So force acting on this will be mv by t. Clear it is? Okay. Okay, fine. So the block B will come to rest only if this external force is equalized by the frictional force, because frictional force is stopping this block, and they are asking the block will come to rest at what time. So if this force becomes equal to frictional force, so F equals to mv by t, correct? And what is F? So F is nothing but mu n equals to mv by t. I hope this is clear. Okay. And what is our n? So n is the normal reaction of this block, so that will be pointing in this direction, and that must be equals to, in this particular horizontal case, it will be equals to mg in this case, right? So if you substitute mu times mg, that will be equals to mv by t. Let's cancel out this m with m, okay, and the time will be equals to v by mu g. Correct? So V by mu g, this is the time after which the block will come to rest. Option A is correct. I hope this is clear. Understood? Very simple problem. Let's see the next one. Again, we have a problem based on pulley. So we have many questions on this. So let's see another one. The coefficient of static friction, which is mu s between block A of mass 2 kg, and the table is shown in the figure, is 0.2. Fine. This is our static friction. Let me just write it separately. Mu s is nothing but 0.2. Great. What would be the maximum mass value of block B so that the two blocks do not move? If both the blocks are not moving, the tension is equalizing the frictional force over here and the tension is equalizing the weight over here. Then only they will not move, right? Okay. The string and the pulley are assumed to be smooth and massless. Take G as 10 meter per second square. Let me repeat again here. The question is saying that both the blocks are not moving. If both the blocks are not moving, this is obvious that if the tension is greater than the frictional force, the block will have a natural tendency to move to the right. If the weight is greater than the tension force, then the block will pull it down. But if the tension becomes equal to the weight and the tension becomes equal to the friction, in both the cases, net resultant becomes 0 and they will be at rest. Clear? So let's assume that its mass here is m. Okay. And here it is obviously tension T. So in the block B, so for B, the tension T must be equals to mg. Clear it is? For block A, the tension must be equals to the frictional force. If these two conditions are true, then the whole system is in rest or it is in static situation, right? Okay. So if T is equals to mg, let's substitute it here. So mg will be equals to the frictional force acting on the second block, block A. Clear? And F is nothing but mu n. So where is n? Normal reaction, upward in direction, weight, downward in direction. Clear? So n is nothing but the weight here in this case. So mg will be equals to mu times, what's the mass in this case? So 2 kg. And what's the g value here? Let's keep it g. Okay, 2g. I'm just putting, that is the weight. So let's cancel out this g with g, and m will be equals to mu, that's 0.2 into 2. And that will be equals to 0.4 kgs. That will be our correct answer. Okay. Yeah, option D is there, 0.4 kg. I hope this is clear. Let's see the next question. Great. Our next problem says a block of mass 10 kg. So mass here is 10 kg, fine, is placed on a rough and horizontal surface, having coefficient of friction 0.5. Okay. If a horizontal force of 100 Newton, so force here is 100 Newton, is applied on it, then the acceleration of the block will be how much? G you are given with 10 meter per second square. Okay. Let me explain the question with you. This is our block. This is our horizontal surface and we are placing a block on this surface, right? You are applying a force in this direction. The friction is opposing it in this direction. What will be the resultant acceleration of this block? Clear it is? So we know that this applied force minus the frictional force, that will give you mass times acceleration of this block. Very simple, straightforward. Okay. Driving force, stopping force, subtract both, you get the resultant. Clear? We have applied this concept in the previous section also. So driving force is how much? 100 Newton. Friction force, sir, mu times n, where n is the normal reaction acting in the perpendicular direction, and here it is mg, which is equal to mg. Mass of this block is how much? 10 kg. Acceleration we are looking for, right? Let's substitute the values. 100 minus, what's the coefficient of friction? So 0.5. And what's the normal reaction? So weight of this block. If m is 10, weight of the block is 100. 10 into 10, correct? M is 10, G is 10, so 100. So this will give you 100 minus how much it is? 50. That's equals to 10A. So 50 upon 10, that's equal to A. So acceleration is how much? Sir, acceleration is nothing but 5 meter per second square. I hope this is clear. Option C is correct for this problem. Clear? I hope this is clear. Let's see the next problem. Our next question says, starting from rest, if something is starting from rest, its initial velocity is 0. A body slides down at an angle of 45 degree, fine, 45 degree, inclined plane in twice the time it takes to slide down the same distance, quite important, in the absence of friction. The coefficient of friction between the body and the inclined plane is how much? Okay. Let's imagine the situation. Okay. We have an inclined plane like this. Okay. Any inclined plane like this. Initially, there is no friction here. No friction. If no friction, I just took a ball and it is rolling down. Okay. Second case, when there is a friction here. Now I am allowing the ball to go down. Now it will take a longer time, right? So that is given that it is traveling the same distance, but the time is double the previous case. What will be the coefficient of static friction or kinetic friction or friction in this case, right? That we have to figure out. So let's take a block here. Okay, imagine the situation. I'll take two situations. The first situation is when there is no friction. So I'm writing here no friction. If some object is placed on it, it is traveling down because only there is one force acting on it, which is mg sine theta. Correct? Mg sine theta is making it move down. Clear it is? So here the acceleration will be g sine theta in this case. Okay? Weight is downward in direction here, and here it is mg sine theta. So mg sine theta is responsible for any block to move in the inclined place in case if there is no friction. If there is a friction in this case, okay, let's say this is a friction in this case, okay, when there is a friction, if this is a block, it is going down with g sine theta. Now there is one additional, sorry, mg sine theta, let me write, I'll just put the accelerations later on. Mg sine theta is making it go down and frictional force is pulling it in the upward direction. Okay, and how much it is? Mu mg cos theta, correct? So what is the acceleration in this case? In the first case, acceleration is nothing but g sine theta when there is no friction. When there is friction, the acceleration is nothing but g sine theta is pulling down minus mu g cos theta, which is stopping it. Correct it is? Okay. So g sine theta here and g sine theta minus mu g cos theta, that's the acceleration in case of a friction or a rough plane. Clear it is? Okay. The question is saying the coefficient of friction we have to find, and starting from rest, both are starting from rest, so u is 0. So in this case our s is equals to, we will make use of ut plus half at square for both the equations, and u for both the cases is 0, so s will be equals to half at square in this case, and s equals to half at square in this case. So let me write the first one here. S, the distance it travels, equals to half g sine theta into t square, t1 square. T1 is what? The time taken in the first case. Let's solve it for friction. For friction, S will be equals to half. And what's the acceleration here? So acceleration here is this part. So g sine theta minus mu g cos theta t square. Clear? I hope this is clear. Be very careful. This is T1, this is T2. Angle is same, 45 degree. Distance is same, correct? Only the acceleration is different in both the cases. The first case it is g sine theta when there is no friction. When there is a friction, it is this much. T1 is here and T2 is there. Great. Let's divide both of them. So if I divide these two equations, S and S will make it 1 on the left hand side. Half cancels with half. And let me write here, I'll cancel it in the next step. G sine theta T1 square whole divided by, there I took g sine theta minus mu g cos theta whole T2 square. I hope this is clear. Clear? If there is no friction, the block is coming down. If there is friction, the block is again coming down. In which case it will take more time. Sir, obviously friction, it will take longer. Here, no friction, it will come fast. Clear? So this time will be higher than this time. By how much time? By how much value? Twice. So T2, which is this one in this case, and T1 in this case. So T2 is twice of T1. Let me use this value also and simplify this our expression. Clear? So let me solve it here. On the left hand side, it's 1 over here. On the right hand side, g sine theta T1 square whole divided by, let's substitute here, take g common in both so that we can cancel out from the numerator. G sine theta minus mu cos theta. And what about T2? This T2 is nothing but twice of T1. So let's substitute here. It will become 4T1 square. T2 is twice of T1. So T2 square will be 4 times T1 square. Let's cancel both. Let's cancel both. We left with 1. Let's put here, substitute the value of angle 45 degree. So sine 45 whole divided by sine 45 minus mu times cos 45. Clear it is? Quite simple. Now, and there is one more expression, 4 is over there. Be very careful with this. It is 4 is there, right? Okay. I hope this is clear. Let me remove this whole part so that we can solve this remaining part of this whole problem. I hope you are getting it. Okay. Let's cross multiply. So it will be 4 times sine 45 degree minus mu times cos 45 degree, and that's equals to sine 45, correct? Let's substitute the values from 10th standard. Sine 45, 1 by root 2, 1 by root 2, because cos 45 is also 1 by root 2, 1 by root 2, clear? Multiply the whole equation with root 2 so that all the root 2 goes and you left with 4 into 1 minus mu equals to 1, correct? Let's take this 4 that side. It will be 1 minus mu equals to 1 by 4. Taking 1 by 4 that side, 1 minus 1 by 4 equals to mu. 3 by 4 equals to mu. And that will be approximately 0.4 sevens are 28, okay, and 24, 0.75. That's our kinetic, coefficient of friction, 0.75. I hope you understood this whole problem. Clear? Let's see our next question. Great. Our next question says a block has been placed on an inclined plane with its slope, with the slope angle theta. The block slides down the plane at a constant speed. If it is moving with a constant speed, this is obvious that resultant force is becoming 0. Okay. The coefficient of kinetic friction. In that case, the coefficient of kinetic friction, we will straight away say that mu will be equals to tan theta. Okay. Straight away, mu equals to tan theta in this case. Clear? If it is moving with a constant, okay, velocity. Constant velocity means net force being 0. Okay. only in case of constant velocity. Okay, let me prove this in case if you have any confusion. Let's assume that this is our inclined plane, this is our angle theta, and you are placing a block. If it is moving with a constant velocity, which means the resultant force is becoming zero. Sir, why you are again and again saying that constant velocity force is zero? Obviously the change in velocity becomes acceleration, and acceleration will be zero. Okay, in this case, so mg sine theta, which is throwing it downward, and mu mg cos theta, mu mg cos theta, that is our frictional force which is pulling it in the backward direction. This net force, which is mg sine theta downward minus mu mg cos theta upward, must be equal to zero, right? Let's take it on that. This is our kinetic friction, this is responsible, right, for the motion of this block. So let's take it on the other side. It will be mg sine theta must be equals to mu k mg cos theta. Let's cancel out mg with mg on both the sides and take this cos theta other side. It will be sine theta upon cos theta will be equals to how much? So obviously it will be equals to mu k, and that is tan theta. So mu k is tan theta. Option D is correct. This is the proof. I hope this is clear. Let's see our next question. Our next question says, consider a car moving along a straight horizontal road with the speed is 72 km per hour. So U here is 72 km per hour. I am straight away converting into meter per second. So this will be 18 forza and this will be 20 meter per second. So the car is moving with 20 meter per second on a straight horizontal road. If the coefficient of static friction between the tires and the road, mu, is nothing but 0.5 in this case, the shortest distance in which the car can be stopped, so v is equals to 0. I hope this is clear. Okay, we have to find, and g here is nothing but 10 meter per second square. Clear? So we are stopping the car. If you are stopping the car, simply means v square minus u square equals to 2as. Clear it is? Okay, I hope this is clear. Okay, so if the coefficient of static friction is this much, the shortest distance, so we have to find s in this case. Clear? Now v is 0, obviously v is 0, u is 20 meter per second, so 400. It will be retardation because acceleration will be retardation, so minus 2a, and distance we have to find. In this particular equation, there are two unknowns. One is acceleration and another one is distance, right? So let's keep it as equation 1. Because we can't find two unknowns with one equation. So we have to find either acceleration in this case. So this acceleration, this retardation, we can find because of the frictional force. And frictional force is nothing but mu n. And n is nothing but weight of this car, mg. This is our frictional force. And this frictional force will give this retardation. A will be equals to mu mg. Correct? M and M cancels, A will be equals to mu into G. And what's the coefficient of friction in this horizontal row? 0.5. So 0.5 into G, which is 10. So A will be equals to 5. And what? It will be negative, correct? So A is minus 5, retardation. Let's substitute here. It will be minus 400 will be equals to minus 2 into 5 into S, correct? 2 5s are 10. Let's cancel out this minus with minus, and 10 goes that side. 400 divided by 10, this is the distance s, which is 40 meters. I hope this is clear. Okay, the car will stop in 40 meters. Clear? Because of this particular coefficient of friction on the horizontal road. Let's see the next question. Great. Our next question says, a heavy uniform chain lies on horizontal tabletop. If the coefficient of friction between the chain and the table surface is 0.25, then the maximum friction of the length, fraction, it should be fraction, maximum fraction of the length of the chain that can hang over one edge of the table. Okay, let me explain you in a simple language. What is happening here is, you have a table in this case. Okay, let's say this is a table, and on this table there is a chain which is placed like this, such that some part of this chain is hanging down. Clear? And because it is hanging, the weight of this small hanging part will try to pull this chain down. But the friction between this chain and this table will stop this force, right? That must be equalized so that this chain will go nowhere. the weight of the small section and the frictional force. Okay, we have to find what is the maximum piece, because small piece obviously it will be stopped, but what is the maximum piece that can hang here so that the resultant will be no force acting on this whole system. Clear it is? This is the question. So for this system, one thing which we don't know, that is the mass. Okay, let's assume that the length of this whole length of the chain, let's assume it is equals to L. If length of the chain is L, then the whole mass, I am assuming, mass of the chain is capital M, I am assuming. Then what is constant throughout this chain? The mass per unit length, right? So let's assume that mass per unit length, I'm defining it as mass per unit length. Now you also have a direct formula, but I'm just explaining, recalling all of your concepts. So that's why I'm solving this whole thing. Mass per unit length will be equals to how much? So this will be equals to our M by L. Let's say this section is X, which is hanging down. If X is the distance or the length of this chain which is hanging down, what is this length? Sir, obviously this length will be L minus X. So can we find the mass of this and this? Of course. What will be the mass of this hanging part? Mass of, let me write here, mass of hanging part. Mass of hanging part will be equals to our M by L into X, correct? Mass per unit length into distance, that will give you the total mass. And what will be the mass of that resting part? Mass of resting part due to friction, that will be equals to how much? M by L into distance, which is L minus X. Clear it is? I hope this is clear. This is the mass here and this is the mass over here. Now let's equate here our other part. So what is here which is equal to this part? The weight must be equals to the friction. So weight must be equals to the friction. I hope this is clear. What is this weight? So this weight will be mass of this part, which is this one, M by L into X, must be equals to the friction force which is acting here. Oh sorry, the acceleration due to gravity I have not included. This is mass, this part is mass into acceleration due to gravity will give you weight. And what is the frictional force acting here? Mu into mg. What is m? Frictional force is equals to mu into mg. M is how much? This much, because this becomes a horizontal surface. So this will become m is m by L into L minus X into g. I hope this is clear. Let's cancel out this with this. L with L, m with m. We left with X is equals to mu times L minus X. I hope this is clear. Okay. Now I hope up till here everything is clear. We got an equation. X is that part we have to find in terms of L. So what I am doing here is I am just solving this whole problem over here. What is the value of mu? So mu is 0.25. Let's substitute over there. So X is equals to 0.25 times L minus X, correct? This will be X is equals to 0.25 times L minus 0.25 X. Let's take it that side. So it becomes 1.25 X is equals to 0.25 L. I hope this is clear. So X will be equals to 0.25 upon 1.25 of L. This becomes our that part. But they are asking the fraction. The fraction means X upon L into 100. Clear? X upon L into 100. That we have to find. So let's take this L on the other side. X upon L. This is that part. L is the total length of this whole thing. That fraction into 100 we have to do. So let me just take first L on the other side. And let's multiply on both the side with 100. So X by L into 100. And let's remove these two decimal points. You got here 25. Let me take it on the top. 25 upon 125 into 100. Correct? Let's cancel out. 25 5s and 5 20s. So correct answer over here is 20%. Now majority of teachers, they straight away gives you the relation here. Okay, you can use the direct relation to figure out this part. Clear it is? Okay, let's see the next question. Great. Our next question says A block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum. So let's imagine this is our hollow cylindrical drum. Okay, let's say this is our hollow cylindrical drum and there is a block of mass 10 kg. Let's say this is our block of mass 10 kg over here. Okay, fine. Mass of the block is 10 kg. Radius of this block is 1 meter. Radius of this drum is 1 meter over here. Okay, fine. The coefficient of friction between the block and the inner wall of the cylinder is mu is 0.1. This is between this part, okay, over here. Okay, this is between this section of this block and this whole cylinder, okay, the wall of the cylinder. The minimum angular velocity needed for cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis. So omega we have to find. Okay. Let me explain you this question in a simple language. Okay, just imagine that there is a bottle. Okay, any bottle. I can't find any bottle right now here in front of me. So let's say there is a bottle. Okay, and in that bottle, the edge of the bottle, outside the bottle, okay, at somewhere you are rotating the bottle. When you are rotating it so fast that something inside this bottle, it sticks on the wall of this. Moment you stop it, it falls down. Clear it is? Now you know if it is rotating, it is having a centrifugal force which is equals to m into centrifugal acceleration or centripetal acceleration, MAC. And what is this value of AC? We know it is nothing but omega square r, correct? M omega square r. Between this block and the surface of this wall of the cylinder, there is a normal reaction acting in this direction, and weight is acting downward in direction mg, and frictional force is acting upward in direction f. Clear it is? So let me simply draw this over here. This is our block. Weight is trying to make this block fall down. Friction is trying to keep it static there. And normal reaction is in this direction, which is equated by centrifugal force Fc. Okay. Let's use these equations to figure out our omega. Clear? So let me first write here our first equation. Fc will be equals to normal reaction, and Fc is nothing but m omega square r is equals to n. Correct? I hope this is clear. Okay, this is our equation 1. And the second equation is the frictional force is equating the weight. And frictional force is mu n, that is equals to weight mg. And what's our n here? N is this. So let's substitute here m omega square r equals to mg. Let me remove this m with m. Omega square will be equals to g upon mu r. Many times this question directly came also. Okay, in JE also you have to straight away find the value of omega, that is root under g by mu r. Correct? So let's substitute here the values. Omega square will be equals to g, which is 10, mu, which is 0.1, r, which is equals to 1. Let's remove this point, it becomes 100. So omega will be root of 100, which is 10 radians per second. In standard units, 10 radians per second. I hope this is clear. Option B. Okay, so very simple concept, yet very useful concept. Okay, let's see the next question. One end of the string of the length is L is connected to a particle of mass M, and the other end is connected to a small peg. Okay, you can say a small coin on smooth horizontal table. Okay, let's imagine that this is our horizontal table here, and this is connecting this is a thread connected to a coin. Okay, fine. If the particle moves in a circle with a speed v, so if it is moving with the particle is moving with in a circular motion with speed v, the net force on the particle will be, of course, it will be the tension T. Okay, this T will be equating this mv square. Okay, outside it will be mv square by r, and this mv square by r is nothing but the tension. Okay, which is acting here. So correct answer is tension T, which is mv square by r. Clear it is? So T represents the tension in the string. I hope this is clear. This is the net force acting on this. Okay, be very careful. Don't make it 0 or don't make it that thing. So T is mv square by r, and that is T. Okay, let's move to the last question for today, and this is a direct problem. Banked road. I hope you have done the derivation. Okay, huge derivation, often they ask in board exams. Okay, so let me come back to this. A car negotiating a curved road of radius r the road is banked at angle theta, the coefficient of friction between the tires of the car and the road is mu as the maximum safe velocity. You should remember this value. It will be equals to the option A. Okay, you have to remember this value. Okay, condition when the coefficient of friction becomes 0, or okay, in that case, from here we can find our value as root under gr. When there is no friction, this will be mu 0 mu 0, this will become tan theta in that case. Okay, we will see that questions in our next lectures also. Okay, so I hope you are understanding this. If you have any suggestions, please comment on this video so that I can give you some better versions. Okay, and we will continue with this in the next class.